Good morning, ladies and gentlemen. Here's our question for you today. How can forces be exerted at a distance without contact?
This is one of the big questions in science over the centuries.
Let's see if we can answer it. First of all, what is a magnet?
I think we got some magnets over here.
It is a magnet. We've got some magnets over there. Check them out. They're totally groovy. Okay, we're gonna come back over here. What is a magnet? So a magnet is a piece of metal that can exert a magnetic force on another piece of metal.
Yeah, here's some metallic magnets.
Metal. Whoa.
Hit it.
Hey.
Yep.
So, a piece of metal that can exert a magnetic force on another piece of metal. Okay, so magnets are bipolar. What does that mean?
Yeah, I know.
Bipolar. That means they have bi meaning two and polar meaning poles. So they have two poles, a north-seeking pole and a south-seeking pole. Let's go ahead and show them on there. Okay, so let's see, the N stands for north, S for south, and so the north seeking pole is gonna try and move until it goes
It's gonna
north, right?
seek the north.
It's gonna seek the north, yeah.
And I think we have an example of that over here because if you'd been in the classroom, you'd know that above the clock, north is this way.
And then, I don't think it's labeled on that side, is it?
No.
Okay. And so this is a magnet, and so the north-seeking pole, the side of the end of the magnet labeled N, I can't speak, is pointing towards the north, and the end of the magnet labeled S for south is facing south.
Wait a minute. Can you guys even see that? I can't even tell if I've got it or not.
Okay, no, right there.
There it is.
There it is.
Thinking, what the deuce are they talking about?
They're like, Miss Moore, we don't see anything.
Well, look,
Yeah.
you could see your finger though. There's
Yeah.
All right, so yeah, you have the
So if you were to
N,
whack that, eventually, even though it would do a lot of spinning, eventually it would line up, right?
and
in
so
the same
there's
spot.
the north end. It seeks the north,
Yeah,
and the south seeks the south.
that's what we mean by north seeking and south seeking. Okay.
Sorry about that bad camera work there, boys and girls.
We're like, we don't see anything. We're gonna see anything. Okay. A compass is a magnet that is free to turn. So does that mean that what we just showed you is a compass then?
I think it is free to turn. Let me just check.
Yeah.
Let me get a meter stick here. And if I
Ever so slightly,
it is free to turn.
it's free to turn.
All right, we'll come
I
back
think
and
in
look at
class
that
we'll go
later.
back to it. Oh, did we ever do remember the stuff in the gel?
Oh, that's in the back. We'll use that on the next lesson.
Okay. All right, so.
Oh, no, we're not ready for this yet.
Oh, but we're gonna show them this, right? We're gonna show them this here.
Oh, yeah. Sure.
Yeah. So a compass is a magnet free to turn. So you guys have seen a compass that looks like this, right? Right, and no matter which way I turn, it's free to turn, and no matter where I turn it, it keeps facing north. Ooh. These guys are kind of messing with it.
Yeah.
Okay, and then also.
Now, what does she mean by that? Well, if you take this magnet, you can make it point in whatever direction you want.
It's messing with it.
Yep.
Okay, and then we put this is free to turn right here.
Within limits.
Yeah, within limits. And so I'm gonna go ahead and south to south.
That looks like it's trying to get away. What do you call it when it's trying to get away?
Repulsion.
I find this person repulsive. I would prefer to stay away from them.
And then, we just oh my God, there's so much.
Can't get too close.
Dang it.
And that's attraction.
Yeah, these are really strong today. Okay. All right, so that is a compass. Compass is just a magnet, which you guys are familiar with, that is free to turn. And all magnets on the north side are going to be north seeking, south side, south seeking. Okay. Now, question for you. How can we make the visible
How can we make the invisible?
visible? Yeah? Okay.
That's the question.
How can we make the invisible visible? Okay, we're gonna do a lap. So do I have anything? No, okay. Boy, when we used to teach, you just like carry it around like this,
I did,
right?
yeah.
Okay.
So now, if we were in school, you would have this lab,
Yeah, let's do it.
and you would be doing this yourself.
Okay, so it says, what are these strange bars? Okay, put a piece of paper over one of the bars. Okay, put it like this. Over one of the bars. Piece of paper over the bars. And sprinkle the iron filings around the paper. Okay, draw a picture of the pattern.
Whoa.
Whoa!
Well, that's really clear that there's something around the bar that's invisible.
Yeah.
You got the bar magnet, there's something around it that we can't sense, but if you sprinkle iron filings on it, it reveals the pattern. So what should they do?
You should draw a picture of this pattern that the iron filings make on this paper in your notebook.
So go ahead.
Yeah, these are totally groovy, right? So they're kind of going out, okay? And it looks like they connect all the way back over here, right?
Yeah, and it's lines. Don't make just a bunch of dots. Even
Yeah.
though there's a bunch of iron filings that are like dots, what's the pattern here? Draw those lines.
And what's really cool is even though you can't really draw this, it's actually sticking out of the paper. Do you guys see that? Huh, so that means it's not just a 2D, it's more like a 3D thing, right?
Yeah.
Okay, so now it says to take this and put it back in here. Okay. All right, so oh no, we skipped number 2, right?
Yeah.
All right, on to number 3. Okay, place the two pairs.
Bars.
Bars.
It's a typo.
Bars with different ends about 2 centimeters apart. Okay, so this is gonna be the south, and then this is the north. 2 centimeters apart, like right
A little
there.
bit more, a little farther apart.
Oh, further apart, right
that's,
there?
That's good right there.
Okay. I was like, what's 2 centimeters?
I know.
Put the piece of paper over the bars, like this, and lightly sprinkle the iron filings over the area between the 2 bars.
Between the 2 bars.
Okay, so that's like right here.
Yeah.
Oops. No.
Okay, you're
I'm too close there.
you're just dropping a big clump.
Yes, literally
Yes,
like.
you can't see anything.
I was like, let me make sure I'm right in between. Okay. Oh, there we go.
Okay, up high. There you go.
There we go.
Wait a minute. Do you have the same? Yeah, go ahead. Lay 'em in between. There you go. Keep going.
Okay.
Keep going. Cool.
Cool. Good like that?
Yeah, here, let me see it. Just for a second.
Okay. Let the expert do his thing. We learn from the best. Oh, look at that.
Kind
Okay.
of looks like a pumpkin.
Yeah, it does. Right there in the middle, even
Yeah.
on that side. Okay, so what do we see here? Well, this is the north, that's the south. And we see that the iron filings are sort of like reaching over across, kind of like the fingers being intertwined, right?
Yeah, like fingers reaching across to grab
Yeah.
onto each other.
Yeah, okay. And then out here, these are connecting here too, and then these are connecting here, and then those there.
So make a drawing of this.
Yeah, make a drawing. What do we see here? Put these guys back. And then I'm jumping to...
Now, what happens if these bars get too close together the way they are?
Oh, and now they are stuck.
So what is that a picture of? What is that, attraction or repulsion?
Well, they're attracted to each other, so it's got to be attraction, right?
Yep.
Okay, so bada boom. Number 4, right?
Yep.
Place the two bars with same ends about 2 centimeters apart. Okay, so these are both the north, so 2 centimeters apart right there. Okay, oops, not that way. All right, and I think it's the same thing. Put the piece of paper over and lightly sprinkle the iron filings over the area between the 2 bars. Oh my gosh, do you guys see this?
Keep going. They are not connecting with each other.
I keep trying to pour them in the middle there, and they're not having it.
And they're actually standing up off the table, too.
Yeah, they're like, ooh. so repulsed.
So we've got
Okay.
the same together.
Mm-hmm.
Make a drawing of that. See what the lines are doing?
Mm-hmm.
So make a drawing of that one.
Yeah, it's almost like they're just like they're peeling off to the side, right?
Like fingers pushing away from each other.
And I bet we could, if we had a 3D, we could, they would be going out this way.
Yep.
Okay.
Yep.
All right.
And that's it.
That's it. Boop, 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 boop.
Now see, if you were here, you'd have your own bar magnets, and then all the
You'd have to do some vacuuming.
go around, pick up all the stray iron filings.
All right. Look at that. Come on, get off of there. Let's go.
See, because the iron filings themselves are not magnetic, but they are metal, and they will.
You see that?
I know. They will respond to the magnetic field. That must be made of iron as well.
Okay. So what do we have next here? I wonder if can we? You guys see that? See the stuff coming outside? And
That's
then-
like that.
Okay.
That thing that had the iron filings under plastic with the face of the man, and you could give him a mustache and all that kind of stuff.
Okay. Oh yeah, here. What does the word field mean?
When you hear the word field, what do you think of?
Maybe like a football field.
Football field.
Or a field of flowers, or
Yep.
a field of tomatoes.
Ooh, I likes
Right.
me some tomatoes.
Fla-
So
oh,
field.
it gives you the flower
That's
field,
right.
Right?
So field is like a place, an area, a space, a region where things happen.
Things happen there, right? Whatever that field is for you. Okay. How can forces be exerted at a distance without contact?
Well, we saw when you had the opposite ends close to each other, they attracted, even
Yeah.
though they weren't touching. And then when we put the iron filings on, we could see that there was something going on between the bar magnets. Yeah.
Okay, so how can forces be exerted at a distance? Okay, so there's some sort of thing going on in between those magnets.
Yeah.
What is a magnet?
I
Well,
think-
a magnet is a piece of metal that can exert a magnetic force on another piece of metal.
Yep.
So, how did we make the invisible visible here? Well, I'm going to go ahead and actually just talk about this. So, we had our magnet here, and we poured the iron filings over the magnet, and what we were able to see, we made the invisible, the magnetic field,
Yep.
visible by pouring over the iron filings on there.
So when you have just the bar magnet held in your hand, you can't see this pattern around it, but that doesn't
Yeah.
mean it's not there.
Yeah.
By the way, before we finish, I want to go back to this bar magnet that's hanging here that we disturbed.
It's trying.
Uh,
There we go. And now it's probably kind of going
it's
back.
stabilizing,
Yeah, it's trying. The string it really has a lot of freedom to move.
but the north is toward the north side,
Uh-huh.
and the south is toward the south side. So after a while,
It'll just chill.
Yeah.
We'll come back tomorrow.
by the way, that bar magnet has been up there for 25 years.
Woo!
25 years, holy.
So if you didn't write that down, rewatch what I just told you. Write it down. We made the invisible visible. We showed the magnetic field lines.
Okay, now the next assignment, I think you can handle this.
Okay, you guys, you guys gonna watch a Bill Nye video, and they're not gonna do anything. They're just gonna watch it, soak it in, right?
It's a great, great video, yeah.
All right, go for it.